Hi students, this experiment is designed to apply Excel and Python to solve ordinary differential equation. In this video, I will discuss how a simple Euler's method can be applied to solve ODE equation in Excel. Okay, for that, I took the equation that is dy by dt that is equal to minus dy. The same equation can be analytically solved through the steps I just given here. You can separate the variables, and after separating you can integrate. You will get y equal to c e power minus 2t. Then after substituting the initial condition, you will get my c value as minus 2, and you will get the final expression yt equal to minus 2 e power 2t. Now the simplest way I can generate, okay, here let me take here t, okay, t value here, my y actual, you can select this words, right click, format cells, yeah, superscript. Okay, now I can give t equal to 1, and before that let me select h equal to 0.5. okay, and t, our initial value problem, t equal to 0, t equal to 0. My next value will be equal to this value plus this cell. I want to take this cell as a reference cell. I don't want to update the cell value for the particular this value. Therefore, I want to insert dollar symbol in front of b and in front of 2. Okay, enter, and you can drag the formula till whatever value you want. Let me drag it till 20, and y actual, I can use this, the final solution, that is y of t equal to minus 2 multiplied by exponential power minus 2 minus 2 multiplied by t value. Yeah, close the bracket. Yeah, now we obtain the initial value as y of not equal to minus 2. I can double click on the square. The formula will be dragged to the entire values, and similarly you can plot the graph, insert, scatter, and you can select both the values. Okay, you can select both t and y. Go to scatter, select scatter with smooth lines and markers, or you can select now I have selected, and what you can give here is right click, select data, and let me edit the series number 1. So I want to have actual value. Okay, now I want to solve through the Euler's method. How that can be done? Suppose I have the complex function which could not be integrated. I can use the Euler's method, simplest way to solve the problem of integration, ordinary differential equation, not integration. The formula for that I have given the PPT. Here, if we look at here, simplest understanding is, here we have here in the y-axis I have f of x, here I have x. This is the curve. This curve talks about change in f of x value with respect to x. So this is the actual value which now we have predicted as per our problem statement. And Euler's method, what does is, our initial condition is given to us, that is x0 is given to us, that is when time equal to 0, y value is given as y0, that is 2 as per our statement. It is a minus 2, it is given to us, so it will be minus 2. Okay, and what I have to do is draw a tangent at this point. Okay, draw a tangent at this point. It will be and extend, and this value is the h value which we took it as starting of the Excel calculation. This is the h value. So from here to here, it is called as x2 value of x1. What is that? x0 plus h is nothing but x1. So here now my y0 is y value at time equal to 0. That is the value here, and my next value will be as per the Euler's formula. Y1 will be equal to y0 plus h divided by f of xn comma yn. It is nothing but as per the graphical view this value. Okay, that is f of xn comma yn. So now we need to extend line where these tangents and this vertical line mean this is my new value as per the Euler's method. So that is the yn plus 1. Actually my values lies here. My actual value lies here. This is my actual value, that is un plus 1. Actual value, this is the as per the numerical one. And this difference is called as error. And this error value will decrease as these h values decrease. Suppose I am going to draw a tangent. Let me show it again. If I am going to draw a tangent by taking h value, this is my new h. Let me take this is my new h. I'll draw a vertical line, and if I'm going to draw a tangent here, it will be around it meets here. Okay, so now if you compare, this is my actual value, this is my numerical value. The error is less while comparing with the when I take large value h value. Here the error value is high. Now let us see in the Excel how by changing the h value how the error changes. Yeah. Now let me apply my Euler's method here. Let me copy paste the formula here so that you can understand easily. Copy. Yeah, I pasted here. Now this is my y numerical. Let me give Euler's method. Okay. Select only the text E. Right click, format the cells, and superscript. Okay, now what is my y value? Same as minus 2 because for the Euler's method the initial condition must be given to us minus 2. Yeah, now what is the next value of yn plus 1? That is nothing but equal to yn. This is my yn. The previous value is my yn value plus what is my h value? This value. And also now I want to take this as a reference cell. I don't want to update the reference cell for next cell. Okay, for that you have to give the insert that makes that cell to be dynamic. Okay, multiply by f of xn. Okay, f of xn is nothing but the This is my minus 2, my minus 2y is the my f of xn. So what is f of xn? You should not confuse with that. F of xn is nothing but whatever term the right hand side of dy by dx is called f of x. So in our case, f of x is the minus 2y. Okay. So for that, let me modify the formula. Multiply by minus 2 multiplied by, what is the y value? That is as per the Euler's method, it is the value of y the previous step. What is my previous step? This is my previous step. Okay. Now I have to take this value as my yn, and we don't, fortunately we don't have value for t in our function. Close the bracket, enter. Sorry, yeah, let me check the formula again. C5 plus h value, that is b2 multiplied by minus 2 multiplied by C5. Yeah. I'm getting 0 because of wrong assumption of h value. Let me change the value h value as the 0.2 here. Okay. Now I'm getting the closer to my actual value. Now let me double click on the square. Okay. And you can observe here, I'll just plot the graph here so that you can easily understand. Right click, select data, add numerical, and x value should be my same as what I had at t, and my y value should be my newly found numerical value. Now click OK, and you can observe here. Let me add legends. The blue color indicates it is the true value. The orange, it is the numerical value. As I'm going to change h value, you can observe here. Let me give 0.3. The difference between the true and the actual value increases. Let me increase one by one. 0.4. Again it increases. And if I'm going to give 0.5, that is our starting case. Yeah, it increases. Okay. Now let me even go to the 1. Yeah, you can check it here. As I'm going to increase my actually, there are a lot of acceleration happens here. And let me give a very small value here, 0.1 here. And you can see here the values of true and actuals merges together. Let me further reduce the value of h value, 0.05. The h value, as I'm decreasing h value, the distance between the actual and true value decreases. Let me further reduce it here, 0.1, and almost all the curves are merges here. Okay, and let me extend this formula even further. Let me extend till even huge values here, and you can check it here, and let me find the error also. Error that is equal to this value minus this value, and I want to talk about absolute value. So for the absolute value, type ABS. I am not bothered about the sign. That is absolute value. Close the bracket, ABS. Okay. So that is the first case is 0, and if you want to extend, the error is almost low, and if you want to increase h value, it will increase to 0.1. What you can observe is the error increases. 0.2, you can observe here error values increases gradually here. So we can observe both graphically as well as the numerically. We can observe as h value increases, the error value increases, and you can even the plot again, the same graph again. I'll show it again. Select 2 data here, insert, scatter, yeah, the platter, and legends I want to enable, and let me select data here. Select data. Let me edit the first one. Show value. Okay. Now I want to add. Okay. Further, add numerical value. X value again. Same thing. I would select entire X value. Okay, now let me select Y value. I have to select my numerical value. Okay, and you can observe the entire graph, and you can, as we have done it earlier, if you increase 0.4, the values are, the error value increases. Also, the difference between the true and actual also increases. Thank you for watching the video. Thank you.